Good morning, everybody. So today's workshop is going to be 3 hours. And I, myself, is a biologist. So the first part, I would be mostly focused on the biological perspective. What is copy number? Why do we care about copy number? And how do we detect copy number, allele-specific copy number, and the loss of heterozygosity? And the second part would be Tom, who is giving you some suggestions on how to design your experiment and do some statistic analysis on your data. Tom has been doing statistics in the genomics field for more than 15 years. So a lot of people I met in the field, they typically ask, who is Tom? I said, Tom is the one who gave in statistics. And they say, oh, I remember that. 10 years ago, I maybe have listened to that. And sorry about that. So because this is a short course, which means we want everybody to understand it as best as we can. And so I will go slower than a normal presentation. So I can pause in between slides so that if you have a question or you didn't completely understand these slides, raise your hand and ask me a question at the same time. And I also understand that I may have accent. I'm not a native English speaker. So if you do not understand me, simply raise your hand, ask me to repeat or explain more, okay? Let's start it immediately. What is copy number? So copy number variation is a segment of DNA in which copy number difference has been found by comparison of 2 or more genomes. So there are several things that you need to pay attention to here. One is the segment of DNA. That means we're looking for a region. Why? It's because the copy number variation is caused by rearrangement, such as deletions or duplications or inversions. So that means when you look for copy number variation, it's not only one probe set that has a higher intensity or lower intensity. You're looking for a segment of regions. And also, there's this word comparison. That means you will need to have a reference, either by your own reference or some public domain available reference. We will talk about this in detail later. But first of all, get the concept about what is copy number variation and what you need to focus your mind on. And how do we detect the copy number? Copy number can be detected by a collection of closely spaced genomic markers. That means along the genome, you will have the genomic markers along the chromosome. Here's one, here's one, here's one, here's one. Very a lot of density. For example, in IFIS SNP6, you may have 900,000 SNP copy number variation markers, and another 900,000 SNP markers. That is very high density. And then use these close-spaced genomic markers. You measure the abundance of DNA across multiple samples. And then you compare against a reference. And this reference can be your own, which is, for example, you do a paired analysis. You have the tumor sample compare against the normal sample to find what is the copy number variation in your tumor sample. Or you can use what else is out there, for example, the 270 HapMap. Use our days to create a baseline and then use it in your study. And of course, later when we talk about how do you make your baseline preference, we will talk about the cons of each of these methods. Yes? You mean one sample for copy number variation? And actually, you can do that because when you are when you are looking for one single patient, for example, you want to study his tumor sample, you can certainly comparing this single one sample to either his own normal tissue such as blood or any of the public available reference.
Are there any more questions?